Hi everyone, this is Muraleekrishna, so my dear friend, and we are going to explore about the world of robotics and vision-based AI in particular. And he has traveled all the way from India to Australia to do his masters as well as PhD. And I think we'll just dive straight to it. So we particularly know that in India, especially when we are doing bachelors in engineering, we don't have an idea when we start to do bachelor's engineering. So did you have an idea in terms that you'll be choosing robotics or AI, or were you the same like everyone else?
I was pretty much same like everyone else, but I had an idea on what field I should be working broadly. For example, I wanted to be an electronics engineer based role. So I didn't know at that time what electronics engineers would do other than building a TV or something. So I've seen TV mechanics come at home and then they fix the TV. I thought, okay, if I want to do electronics, then I'd be fixing TVs.
Yep.
So that's the only field I knew what electronics engineers would do. But as most of the people, I started doing something like I did my bachelor's in electronics and communication, then slightly deviated to mechatronics, which is a blend of multiple other fields. Then I've now switched to computer science. So my PhD is currently in computer science.
Yeah. Okay.
So to conclude, my initial thought was I would be an electronics engineer. I didn't end up being an electronics engineer.
Okay.
Just that you should make sure that you look out for the opportunities and the path will be clearer to you. So initially nobody knows what field lays out there, but later on when you learn more about your degree and what's out there, then you can particularly focus in on what you have to do. That's what I did.
So usually the trend is like in the later parts of the engineering degrees, like third and fourth year, you start to get some clarity, and that's where you like make contacts or make some extra efforts to do extracurriculars. Is that something like similar sort of trend that you followed?
So we had a group called High Performance Computing Team, which was created by a previous student of my college who came back later on.
Okay.
He started this group where we could do anything outside the curriculum.
Okay.
So he thought of projects that we could apply our skills. Say, for example, electronics engineers could develop small projects, and then maybe those projects are useful for the college. One of the projects I remember we designing was a key management system, where how there are hundreds of keys used in our college. So how do you track those keys? Who has it, and how do you make sure that is given back? So this you can find a computer science student solving the problem a particular way, electronics student solving a particular way, electrical student can. So we were all put in one team, grouped in separate teams, and then we were asked to design a solution. So that was one of the starting point of me thinking outside the curriculum. Okay. So from that day onwards, I thought, okay, what is my actual need? When I started, as I said before, electronics engineering, what was my only field I knew about. But then I thought about I can also do programming.
Yep.
So why can't I think of a field that includes electronics and computer science? Then I started learning Python.
But I think the key is start encouraging people to take part in like those activities rather than sticking to your curriculum.
Of course.
Yeah, you build your networks or you build sort of the skill sets that you can sort of sidetrack towards. But it's all the things that you do it then, otherwise you won't even get it.
Of course, when you just follow the curriculum, what you know is what people already have done.
Yeah.
But if you want to know what you have to do, you need to explore more.
Yeah.
So only some people would already know from the beginning what they have to do.
Yeah.
But unless you explore what's out there, what fields are there, then you can think, okay, this mixture of skills are needed for my career growth.
Yeah.
So I found that in this particular team. So even outside this team, I started looking at what are the employable skills I need. So I learned more of Python, Linux. At that time, I don't think people in my locality would think about Linux or anything, but that group were using Linux. Then I thought that is some OS I should be working on. So based on that, I think when I look back from now, what I did outside my curriculum is what actually helped me.
Yeah, correct. Yeah, okay. Yeah, I think you had few years of experience before you moved to Australia for doing your masters, but like working in India is high-paced environment, and you get lots of technical exposure. All that is fine, but when you are doing that role, did you have sort of in your mind that This is good. I've been doing this for say 2 or 3 years, but I want to explore something further.
Yeah.
Did you have such a moment?
Of course, my first job role was completely different compared to what I'm doing now. It was I was a web developer at that time, so I was dealing mostly purely on software, and that too on mobile and web-based applications. So at that time, I was comfortable. I was getting paid very well because it was a startup.
Yeah.
People were throwing in money at that time, but I thought this is not it's not fitting my kind of thought, because after a point it becomes redundant. You are basically solving same kind of problem over and over, and very few technical challenges in the role. So I thought I should be exploring more.
Okay.
And what is the next step I knew was to get a higher degree,
Yep.
which is more aligned to what I want to do.
Okay.
That's why I thought I would come to Australia, and then
The what you wanted to do was kind of determined when you were doing the role. It's like a light bulb moment, or were you like progressing towards I'm doing these things, but I'm also interested in this thing that I want to focus on, and hence I'll move it over there.
Yeah, so since I started my engineering degree, I knew that I needed to do a part of hardware-based
Okay. Yeah, okay.
technology and software-based
Yeah,
technology,
that's of your
not
liking.
focused. Yeah.
Okay.
So in my first job role, I only got the software-based, so I was not able to do anything hands-on.
Yeah, okay.
So I thought for me to find a particular job role that has mix of
Mix
both.
of both, yeah.
I should be doing mechatronics, which
Okay.
is a degree has both mechanical part of things and electronics. So I thought I'll do a degree in that in
Which
Australia.
paves good way to what I'm going to ask next. It's like you're in a well settled job, and you're planning to move to a new continent which you haven't explored before, and you're planning to do masters as well. How was your mindset then, like back when that all is happening?
So I was already comfortable, as I said, comfortable in my
yeah.
job. It took a very long time for me to decide that I should be actually stop doing this work at all. It's not just thinking about moving to another continent.
Yeah.
Just stop whatever I was doing. That took a very long time. So for that, I was doing. I thought I'll stay in India itself. So
Okay.
I started preparing for GATE. When I talked to my seniors who have done studies in electronics itself, in say IIT or NITs, they were saying there was very small scope in higher studies in India at that point. Maybe it's different. It was not true at that time, but that's what the feedback I got from them. So I thought I should be looking at a different country altogether. So I started applying to US and Australia, and then an Australian university accepted me. That's how I got into ANU, that
Yeah,
I
okay.
met you.
I'm just thinking on how you have to shift your mindset because you're already working, and as part of being part of a workforce, you're always in execution mode. And when you're doing masters, it's sort of like explorative. It's like almost shifting from executive mode to exploration mode. Was there like a big change that you'll have to do?
If you keep learning something during that phase, you're calling it executing phase. So at that time, the main problem is you're not learning
Yeah.
anything outside your work.
Exactly.
So you're locked in there. But even that time, I was learning something. Somehow, I kept learning courses from massive open courseware.
Okay.
Like say edX or Coursera at that time. So I was used to learning new
Okay,
things.
upskilling everything.
Yeah, so
Yeah.
so it was, I think, easy for me to take a decision to move to a different continent or learn further. Just that breaking off from my comfort zone took longer.
Yeah.
But getting into a university, start learning again, was easy for me.
That's good. Yeah. And when you were doing masters, you have completed a PhD now. Was there like a moment when you're doing masters that you kind of knew that this was what I wanted to like hone on into, like develop my skills into?
Yeah, of course. When you remember, we did a robotics
Yeah.
course in that. So during that time, I was looking at SLAM and all the particular topics we were covering during that time. So I thought, what is the research they are doing? And I drilled deep into that and found out that they were doing something related to vision and language. At that time, language was not as big as now it is because
Yeah.
of ChatGPT and stuff. But still, they were developing robots that were following how to deal with language and vision at that same time.
Okay.
So I thought, okay, if I want to
I think breaking it down, So it's like language and vision, meaning you giving certain instructions,
Yeah.
and then the hardware, which is the robot itself, taking those instructions, making sense of what the words are,
Exactly.
and then to validate whatever it's receiving from like vision-based inputs like cameras or whatever,
Yeah.
and then performing set of actions.
Yeah. So
okay.
simply said, there is just a robot with a camera, and that's it. So in that
Okay.
robotic system, you attach Alexa or Google
Okay. Yeah.
Home, and then you basically connect them, and then that robot just follows your instruction.
Okay.
So you just tell it to do like find me a spoon or wash those dishes. You should be able to interpret that, identify, break down into small tasks like navigation, washing,
Yeah.
placing it in a cupboard. So break it down to smaller tasks and performing. Basically, that's the
Yeah, okay.
challenge I'm facing right now.
Okay. And you obviously mentioned that you had certain interest towards robotics. Were there like eye-opening moments when you were learning masters that you didn't know before, like concepts like navigation and other stuff was essentially very new to me when I was learning masters, and I didn't know that I was in a particular impression that robotics was just like humans, an android form. But then I started to explore like there are different kinds of robots. That's from me. But did you have any sort of findings?
Yeah. So like you, I had one end of the spectrum figured out, like where the robots are fully humanoid, human-like, and I also had an understanding of robots which are purely industrial.
Yeah.
So I knew the welding robots were
Yeah.
usually. So I only knew those ends of the spectrum. I didn't know there were social robots that are not looking like humans but
Yeah.
still useful in the market. So that only came to mind. I didn't even know there were vacuum-based robots in market.
Yeah, exactly.
So we worked on projects where the robot is a vacuum robot. They attach laptop to it and then make it work. So that's the first time I knew, okay, there is other robots that are already in market
Yep.
that we have not.
Which is exactly doing what we're learning.
Yeah, so that's not found in India at all. We are not given those robots to learn on. So that was an aha moment for me. Since then, all the moments I had in robotics were aha moments,
Yeah.
because I didn't know there were already people working on vision, language, navigation. That
Exactly.
particularly
Yeah.
my problem. I thought robots were basically stuck to these two ends. One is unachievable at that time,
Yeah.
where humanoid looking, human behaving robots were not achievable.
Yeah.
You could make a robot that looks like human, but it's all mechanical, like but not Indian kind of robot
Yeah,
at that
exactly.
time. Yeah.
Yep. And as you said, like an eye-opening moment for me was computer vision. That the topics in itself.
Yeah.
What is it? And it's not just with cameras,
Yeah.
and it's not just to do with what we know as vision, and what we take granted from what vision is made sense from us.
Yeah.
Those things were like an eye-opener for me. But I think after masters, you moved to Perth where you did work for Hitachi. We all know like Hitachi is like across everywhere. Can you like explain few of the very interesting projects in a very small gist that you did?
So in Hitachi, I am my title is onboard and service engineer, which basically tells nothing. But in the role I am doing, we deal with autonomous trains. So autonomous trains are trains which are driverless. So you just give a train schedule, just tell it what time you have to start, what time you have to end there, and at a particular location, and what speed you should take. So in one line, it sounds very simple, but it's very complex when you start building this kind of stuff.
Yeah.
So how do you locate a train at one point? How do you make sure the train is at that location? How do you make sure the train stops when there is a danger? So
Yep.
if it is working in a very complex or very complex weather pattern, how do you make sure that
Okay.
the train is able to work?
And these trains are completely autonomous, so meaning they don't have a driver inside, or
There is no driver in the normal operation.
okay.
So if it is stuck at some point because of a known failure, that for example, we have the trains usually have something in the front called a cow catcher, which is a grill. Okay, so that grill is in front of the train to make sure nothing rolls underneath it when it hits it. For example, a cow or a kangaroo in Australia case, they might stand on the track.
Okay.
So the train can come and hit it, but the body of the body of the cow or kangaroo can break off and then keep rolling underneath the train and can damage stuff on the train and on the tracks.
Okay.
So to prevent that, once the train hits something, we have some sensors on the front
Yeah, okay.
grill, which called a cow catcher, and sense that incident,
Signal,
and
yeah.
then send the incident report to the train controller.
Okay.
Train controller has to decide whether train should stop or not. If there is no response from the train controller, it will stop.
So when you were doing this project, right? As I asked before, did your research mindset come into play, or did you wanted to career to continue towards this?
Yeah,
So you
so
started doing your PhD on the side, on parallel, I mean, and you're still working in Hitachi. How do you balance your
yeah,
mindset?
so when I started my masters itself, I think I wanted to continue my career, and become more research based, be in a research based role. So even before starting my work in Hitachi, I thought at some point I'll do a PhD, but I didn't know when I'll be
Okay.
doing it. So joining Hitachi and work there doesn't completely influence me taking a PhD, because I already had a plan of taking a
Yeah.
PhD at that point. So, but the role I do at Hitachi has a lot of things that I would be doing at my PhD, because
Yeah.
location sensing, identification, etc. is all part of it.
People usually say there is a very big difference between academia and your working environment, right? Did you find that quite often? And when you started to do your PhD, uh, was there like many big adjustments that you needed to do?
Yeah, so the industry role I am doing it at Hitachi is already set. We know what we have to do. So the uncertain part is only technical. So how do you solve this problem, etc. But it's already bound by your business.
Okay.
So business
Yeah,
knows what exactly we have to do. We just do it. There
Yeah.
are some challenges. But when you're coming to research, it's an open field.
yeah,
You have to define your own problem, and you have to find your solution.
Yeah.
So there you're basically working cutting edge. So this is two different types of thinking patterns. One is you already given a boundary. You don't have to go outside that. Basically a contract basis.
Yeah,
So you
exactly.
just,
Yeah.
but in a research, you don't have a contract. It doesn't tell you how far you should be going. Are you going in a wrong path or
Yeah.
anything? So it's up to you to control yourself. Yeah.
Because you'll probably switch your mindset when you're going to go into that mode.
Yeah.
Okay, yeah, I get it. So can you explain in simple words, as if you're explaining to a small kid, what your PhD problem statement contains?
Yeah. So I hope that kid knows what
Yeah.
a robot is. So robots are, say, like any car or anything that can run by itself. So in our cars, we have drivers who drive the car. But think about, there is not a driver in it, and the car drives by itself. We just tell the car where to go. Just get inside the back seat and just say where to go. So think about a house, and there is a robot inside it, and the robot only has a camera. So camera is similar to our eyes. It can send images or whatever it sees to its mind inside it. So you're just talking to the robot like how you talk to a normal person. Like, I want a pen, I want a spoon, etc. And the robot will go and get it for you. But that knowing is very very difficult task.
Okay.
Because humans like us, we can know stuff, but robots can't.
Why doesn't the robot know these stuffs?
So knowing is a very complex problem. Okay. When you say people know something, there is one definition of knowing, the word knowing there. But when you talk about robot knowing things, it's basically you think it knows, but it's basically breaking it down to simple tasks.
Okay.
But as an outsider, when you look at a robot, you think it's knowing things.
Yeah.
Just for example, in ChatGPT, let's come to ChatGPT. You think ChatGPT is thinking. Okay, but research would tell you that it's not thinking like how humans would think. It's basically trying to make sense of how words act together, and then based on that, it gives an output.
Okay.
So it's actually not thinking; just has a very good knowledge of English language. Similarly, when I say robot knows, and not saying the same, using the same sense of knowing as like we humans know. It's basically trying to align or connect what it sees to what it hears.
Yep.
So if it sees, for example, a TV, and the instruction has a word TV,
Yeah.
it knows, I'm in this location.
Okay.
That's it.
Since we spoke about ChatGPT, how different is your project compared to the newer ChatGPT models? Like, because you can input like an image and ask anything in relevance to the image or context of that image, and you can get an output
Yeah.
from that. It's quite similar to
It's,
your.
it's not. In ChatGPT, even though it can do multiple tasks, it's not good in solving a very particular task. So it's a mathematical problem solving. It can do really well. But there is something called a chain of thought. Like if you ask it to solve a particular problem and ask it to explain it to you back, then you will identify problems with its way of thinking. So
Is that where the hallucination comes
yeah,
in?
yeah.
Okay.
So hallucination is where it thinks of an answer and then tries to fit everything for that answer.
Okay.
But when you ask it more and more questions, you figure out there are flaws in its thought,
Okay.
the thought process, which
Yep.
is still in double quotes.
Yep.
So in my problem, I'm solving a particular sub problem of all this where navigation is the output.
Okay.
So there is a visual input, like you said, you give to ChatGPT, and there is a language part, like you give to ChatGPT. But the output is going to be a planning decision, like what is the next step the robot has to take.
Okay.
Okay. So newer models of ChatGPTs can do it really well, but when I've conducted experiments on ChatGPT previous models, for example, you start from point A, take these steps and end up in point B. Can you create an instruction so that the robot can come back to it,
Okay.
to the starting
Yes.
position? So these kind of problems are very hard for ChatGPT to solve because you have to think back on what you have done previously,
Yeah.
trace back and reposition it.
Okay.
But the real problem here is, like humans, we cannot imagine what a room will look like from behind. So you're moving forward, you can imagine what that room would look like, even though you're not there.
Yeah. Yeah.
But ChatGPT, that kind of knowledge is not there. So what would a room look like from the opposite side? So only then you can think about an instruction going back. So those kind of knowledge is not there in previous models of ChatGPT. Now I've not looked at the latest models, but previous models didn't have that.
And especially when you are attaching motors and actuators to this ChatGPT model, this entire project would be like in terms of scope, right?
Yeah. So there, even though my current project is only on simulators where we assume the world is perfect, there's
Okay,
no
okay.
noise or anything, but still that's a challenge because we need to associate what the vision input is
Yeah.
giving to the robot and what the robot what we want the robot to do
Yeah.
through instruction. So that's one problem to solve. Only later we
I'll
think
pause
about.
you a bit for a second. Can you explain simulators in this context?
Yeah, so simulators are basically a copy of real world. Just that you are not completely copying everything because it's complex. So instead you select certain aspects of the real world and then copy it into computer like that. So for example, a game is a very good simulator.
Okay. Yeah.
In a very say Witcher or any open world based game is simulating the nature really well.
Okay.
So
Yeah.
there is water flowing, etc. It's kind of a simulator. But in computer science, when you do experiments, you don't want that big complex simulators, but you simulate a small portion of the world.
Yep. You constrain yourself to just the problem.
Yeah. So
that you're
what
solving.
kind of physics do you want? Do you want realistic physics?
Okay.
That will be really complex. What kind of lighting conditions you want, etc. You can if you can control it, but it won't be very similar to it won't be same as the real world, but it can be closer.
Yeah, okay. Yep. What usually is like the end goal from a PhD? I know that it stops when you are granted a PhD, but what can you do after it? Obviously, I've seen people start doing their own business by converting what they have done into a product. Is there any other sort of ways?
Yeah, it's not all PhDs where you can convert your problem directly to real world because there are people who work on abstract problems. So there's a very long gap between the real applications of it. You can find it, but just that it's not directly transferable by a year or so.
Yep.
So there are say theoretical problems in mathematics and even computer science you can translate it that right away. But in engineering, you can. Once you finish your PhD, you can continue as a postdoc, where you work on the same problem again for some time. Those are common in Australia. Or you can join a research heavy company where they have a dedicated research team working on theoretical problems, and they have a very small gap between the problem they're working on and the real application.
Yeah, okay. Understood.
Yeah.
Cool. I think we had a very good discussion on this.
Yeah.
If you were to give some sort of advice to the upcoming generation, so if you were to give an advice to like your older self when you were younger, what sort of advice would you give? Like if they are very keen to choosing robotics as their career?
I'm not at a point to give advice to people because I'm not. I don't think I've
Yeah.
achieved yet.
It's like transferring
But
your learning.
yeah,
right?
so my learning would be always keep learning.
Yeah, okay. Yeah.
So whatever stuff you find on the field you are keen on, for example, not just robotics, any field you are on, keep an eye out for say books or journals or even website that talk about it a lot.
Okay.
So in this current era, you have all these websites that you can keep following to see the news of what's going on in that field. When you keep following that, you will know what's going on in that field and make sure that your interest is same.
Yeah, okay.
After some time.
Yeah.
If you lose your interest in that field after just reading stuff from online, then you can be sure that it's not my field anymore. So it's just that keep an eye out for what's happening in your particular field. If it's not fitting you after some time, find another one.
Yeah, okay.
There's always a field for you because there's one anecdote where people are interested in space, space technology and stuff. Then they start doing research in that, figure out it's not what they're doing in real world anymore.
Yeah, okay.
So it's not always black holes and everything. They have to do some abstract problems. So it's similar to in robotics also, where you know there is lots of bells and whistles in media that robotics can do, might not be reality.
Yeah, okay.
So when you read these journals, you will be pulled to the ground level saying these are the actual things going on.
Okay.
Even though there are some people promising intergalactic travel, but the thing is, reality we are dealing with this kind of problems.
Yeah, okay. Understood.
So keep an eye out for these articles and journals.
Yeah, okay. Yeah, cool. I'll potentially have a link where they can contact you and like for anything. And I think that's all for today.
Thank you for having me.
Yeah, thank you.
Okay.